folks, welcome to section 7.3. So we're going to solve systems of nonlinear equations and inequalities in section 7.3. So we're going to solve systems of nonlinear equations with substitution and elimination. And we saw those with linear equations. And if you hear this fancy word nonlinear, it means the variable, the exponent on the variable is larger than 1. So where something like x plus y equals 2 would be a linear equation, x squared plus y equaling 2 would be a nonlinear equation. Then we're going to just graph nonlinear inequalities. You've graphed linear inequalities before. We're just going to do nonlinear. And then we're going to graph systems of nonlinear inequalities. So we'll solve some systems, all right, with equations, and then we'll look at inequalities. And in terms of systems of nonlinear equations, right, system of nonlinear equations is a system of two or more equations in two or more variables containing at least one equation that is not linear. And I know that sounds real fancy, but it really means like I could have a system of equations, like I was saying, like x plus y equaling 2, and then x squared minus y squared equaling 2. That would be a system because there were two equations. They each had two variables, and at least one of them was not linear. All right, so again, a linear equation, it takes the form ax plus by plus c equals 0, right? So in any linear equation, x is raised to the first power, y is raised to the first power. That's how you can spot it's a linear equation. And any equation that can't be written in this form is considered nonlinear. So let's take a look at a couple of cases. I'm going to scooch this page up. Oops, give me a moment. All right, let me move this up so we can get a good look. Let me move this all the way to the top. I can almost get this in. Okay, so we're going to first look at the case of when you have a parabola and a line. So a nonlinear equation and a linear equation. We'll start there and then we'll build up from there. All right, so if I have a system of nonlinear equations, right? Again, two or more equations containing two or more variables where at least one of them is nonlinear. Let's say I have that, right? And let's specifically say I have the parabola and the line version. Then when we talk about where these might intersect, right, or where we might have possible solutions, sometimes we have the case where the line and the parabola never meet. Sometimes we'll have the case where the line and the parabola meet at exactly one point. You might have heard of that word tangent before, right, where the line is tangent to a point on the parabola. And then probably the most common version, or one of the more common versions, is when you have two solutions, when the line hits the parabola twice. So these are systems graphically. This system has no solutions because there's no intersection point. This system has one solution because there's exactly one intersection point. And this system of nonlinear equations has two solutions because the line hits the parabola twice. So we're going to flip the page to example 1. And then we're going to practice all of this algebraically. Like here's the graph version, we're going to do the algebra version. All right, thanks so much. Hey folks, let's take a look at our first system of nonlinear equations. So it's to solve the given system of equations by substitution. All right, and we're going to talk about substitution and elimination in this section, but this particular one, they're saying go ahead and do it by substitution. So if I just take a look, I have 3x minus y equaling negative 2 and 2x squared minus y equaling 0. So this is the equation of a line. If I wanted to, just side note here, right, I could solve for y here and get y equaling 3x plus 2. Right? If I moved the y to the right side of the equation and the 2 to the left side and then wrote it in the other direction, right? Wrote the equation with the y on the left side. This equation, it's an equation, but this equation here is actually a parabola. So let me show you how I could spot that it was a parabola, right? That's supposed to be an arrow. If I move the y over, right? If I add y to both sides, but again, I write it in the opposite order, I would get y equaling 2x squared, and that's one of our toolkit functions, right? That's your parabola that we're used to, except it's been compressed a little because it's got the 2 of the multiplier 2 in here. So I'm trying to look at when does this line overlap this parabola? Like when do they intersect is probably a better way to say it. So if I want to substitute, if I look at these variables here, I think the easiest thing for me to do is solve for y in either of these cases, right? Maybe I solve this equation for y, which I already did, or solve this equation for y, which I already did. And let's pretend I hadn't done this work over here. I would probably solve this linear equation for y and then substitute it into the quadratic. So I'm just going to say I would solve this equation for y, and then I'm going to substitute that into the other equation. This is not the only way to solve this particular problem. It's just a path, right? Again, I could solve this equation for y and substitute it in there. That would totally be valid. I could solve this equation for x and substitute it in here. It'd be a little bit trickier, but I could solve this parabolic equation, or I should say quadratic equation for x, and substitute it in there. So there's a bunch of paths that will get you to an answer. We should all get the same answer. We just might arrive differently. So I've already solved this equation for y, right? We are working with, if I had, and just, oops, I didn't even write that correctly, just if, in case you want to see it. Right, if I had 3x minus y equaling -2, I would add y to both sides. And at the same time, I would add 2 to both sides. Right, because by design, these y's will cancel and I'm left with 3x plus 2. And then by design, these 2's will cancel and I'm left with y. And again, for me personally, I prefer to write it as y equaling 3x plus 2. So I'm going to keep that in mind because I'll need to use that later on. But now I'm going to substitute that right in here. And I need to be careful with that subtraction sign because I do have a binomial here, so that always gets tricky. So here we go. So let's say, and let me put a little separation here, if I had 2x squared minus y equaling 0, and instead of y, I want to substitute 3x plus 2, I'm going to have 2x squared minus, now in parentheses, 3x plus 2, which is equal to 0, right? Now I'm going to distribute that negative to that entire binomial. So I'm looking at 2x squared minus 3x minus 2 equaling 0. And now I have a quadratic equation, okay? And we've talked, there's 3 ways to solve a quadratic equation, right? You can factor, you can complete the square, or you can use the quadratic formula. Now, completing the square and the quadratic formula will always work. They're just going to take a little bit longer. And I personally prefer factoring. And you could use the AC method, you could use whatever you want. I'm going to go ahead and guess and check. I'm going to see if this can factor. And if it can, great. And if it can't, then I'm going to go to the quadratic formula. All right, in terms of things that multiply to 2x squared, I've got 2x and x. That's my only option. In terms of things that multiply to 2, I have 1 and 2. But it will make a difference if I put the 1 here, the 2 here, or the 2 here, the 1 here. Right, I might get different options and I want to see which one actually works. So just for trying this, let's put the 2 here and the 1 here. And I don't know if it'll work. And actually my guess just looking at it is it won't, because I can see if this was the factor, it would have a GCF of 2. And this doesn't have a GCF. So let's see it fail, right? If I did inner, 2 times x is 2x. If I did outer, 2x times 1 is 2x. There's no way to get 2x and 2x to add to -3x. So this isn't the way. All right, let's try 1, 2 the other way. And I want to say, if this doesn't work, if this doesn't actually break it down and factor, then I am going to go to the quadratic formula. All right, but now if I look at inner, 1 times x is just x. All right, and if I go outer, 2x times 2 is 4x, and there is a way to get 4x and x to add or subtract to -3x. If I put the negative here and the positive here, so I'm going to put x minus 2 and 2x plus 1, okay? Now when I do that, I've got the zero product property now, so we know either 2x plus 1 is 0 or x minus 2 is 0. So if I solve this for x, right, subtract 1 from both sides, divide by 2, I'm going to get x is -1/2. Or here, x is 2. So those are my 2 x coordinates. But when you want to solve a system, you want to solve for the x and y. So we need an ordered pair. So what I can do is I can take x being -1/2 and 2, and I can plug it into either of these 2 equations. I can plug it into 2x squared, or I could plug it into 3x plus 2. And just for my own brain, I'm going to go ahead and do 3x plus 2. Because I just think that'll be an easier formula to plug into. So let's go ahead and finish this out. So in the case when x is -1/2, I would get y would be equal to, instead of 3x plus 2, right? Or I can point here or here. Same equation, 3 times -1/2 plus 2. Or I would have y would be equal to 3 times 2 plus 2, right? So I'm either plugging in, oh, and can we see all of that? I'm just trying to make sure, yeah, you can see that. Just want to make sure it doesn't go off the view screen. I'm plugging in x being -1/2 and then x being 2 to 3x plus 2. All right, 3 times -1/2 is -3/2. -3/2 plus 2 is +1/2. 3 times 2 is 6. 6 plus 2 is 8. So my end game answer, I'm going to go ahead and put them over here. My overall solutions, and I'll put the little therefore to seem fancy, I plugged in -1/2, and I got 1/2 back out. And then I plugged in x being 2, and I got y being 8 back out. And for this particular problem, since I was actually able to solve both of those equations for y, I could check my work on my calculator. When you get into more convoluted equations, sometimes you can't solve those equations explicitly for y, so you can't use technology. But here I can. So let me go to my calculator and hit y equals, and you're going to see I already put those equations in because I'm fancy like that. So we got 3x plus 2 and 2x squared. Now I'm going to hit zoom 6. All right, so let's hit zoom 6. And let's just see, we're looking for -1/2, +1/2, and 2, 8. So as I look at this, I can see there's an intersection point here and here. And this could be -1/2, +1/2. That might work. And this also could be 2, 8. So let me go ahead and check. So I'm going to hit second trace. Right? And when I hit second and trace, I'm going to do option 5. I'm going to call it my intersection function. And there are 2 intersection points, right? We've talked about how there's the intersection point at -1/2, 1/2, and 2, 8. Your calculator is happy to go find both of them, but it can only do one at a time. So let me hit option 5. Do I want one of my equations I'm looking for an intersection to be 3x plus 2? Yep, so I'm going to hit the enter key. I would like the other one to be 2x squared. I'm going to hit enter. And I'm going to go after -1, or what I'm thinking is -1/2, 1/2 first. So I'm going to move Blinky closer to that, right? I'm going to be closer to where I think -1/2, 1/2 is than 2, 8. And just hit enter through guess. And there it is, -1/2, 1/2, or -0.5, 0.5. So I'm going to rework that and look for 2, 8. So second trace, option 5. Right, and you can't see it. You can either scroll down to the number 5 and hit enter, or really, if you this finger is just gonna hit the number 5. All right, I'm gonna do enter again because I do want the line and the parabola to intersect. But I'm gonna move Blinky closer to 2, 8. Oops, why is it not letting me move? Huh. Well, that's fun. Let me go ahead and guess something closer to 2. Just to move Blinky over there. So I actually don't know why it wouldn't let me move Blinky. That's new to me. But if it won't let me move Blinky, I'm going to put in a guess of x equals 2 and hit enter. And then I do get 2, 8. All right. So if you run into that real-time problem where Blinky won't move, just guess the x value. So it moves Blinky. It did move my little marker much closer to where the ordered pair was. Not even much closer. It moved it to that ordered pair. Yeah, just type in the x coordinate. All right, thanks so much. Bye.